Today we're going to be talking about the Altair 8800B. The Altair 8800 is a microcomputer designed in 1974 by MITS and based on the Intel 8080 CPU. Interest grew quickly after it was featured on the cover of the January 1975 issue of Popular Electronics and was sold by mail order in other hobbyist magazines. The Altair is widely recognized as the spark that ignited the microcomputer revolution as the first commercially successful personal computer. The computer bus designed for the Altair was to become a de facto standard in the form of the S100 bus, and the first programming language for the machine was Microsoft's founding product, Altair BASIC. Programming the Altair via the front panel could be a tedious and time-consuming process. Programming required the toggling of the switches to the positions corresponding to the desired 8080 microprocessor instruction or opcode in binary, then use the deposit next switch to load that instruction into the next address of the machine's memory. This step was repeated until all the opcodes of a presumably complete and correct program were in place. The Altair 8800B, the second and last of the 8800 series, was an improved version of the 8800 model, of which it corrected some drawbacks. Externally, the case had more professional design with a smarter backlit front panel, including a modified toggle switches, and 5 new functions allowing to read, write, modify CPU accumulator. The name Altair comes from Star Trek. The young daughter of Popular Electronics magazine gave it the name of the destination planet of the Enterprise from the episode she was watching. Internally, the motherboard could support up to 18 S100 connectors. It was powered by a stronger power supply unit, 8 volts, 18 amps, and the CPU board was also modified. New 8080A processor and Intel chipsets. However, the 8800B still remained compatible with all 8800 hardware and software. The system had no bootstrap ROM. User had to thus enter a boot program using panel switches each time the system was switched on. However, every 8800 owner quickly bought or built additional cards to expand the RAM and ROM memory and connect external peripherals. This machine has 2 4K memory cards for a total of 8K, plus, in ROM, Microsoft's Altair cassette BASIC on 1 ROM card. And now I'm going to demonstrate this machine. So the first thing I'm going to do is power it on. And as soon as it powers on, there are some lights that come on, but not a tremendous amount. There's different switches here that allow you to look at the memory locations, examine memory locations. So right now, I could just simply say examine, and it'll then say, okay, as we're examining, what's in memory location at 00000, 8 zeros. And then as I go to next, we would increment right now the different address, and it will then show me what's in those memory locations. Right now, there's nothing in those memory locations. They're all empty. And since we have a ROM card in here that has the Microsoft cassette BASIC, which is right before the extended BASIC, we're going to be using it to actually execute and look at how one would use this machine. So what I'm going to do is I'm going to do a reset again, which resets everything. And when you see the reset switch goes on, everything is displayed, and then we have a general reset that happens. And by me just pushing the run button, the ROM card will automatically start at the designated memory address, which will start Microsoft BASIC, cassette BASIC. So as soon as I hit run, you'll see multiple lights have now come on, and we're looking at the memory location for this, and I believe it's at 14,000. So memory size, I need to enter in the memory size. Well, this machine only has 8K of memory. So I'm going to put in there 8,000 as my memory size. I'm going to hit return, and it would want to know what type of line printer. We're going to use Okidata, which was a typical type of line printer at the time, and I'm going to put in a no for that. And it now says we have 6,948 bytes free. So a little bit under 7K free. Now this machine only has 8K of RAM, but because we're using the card, the 11K ROM card, it's a 12K ROM card, we can load the cassette BASIC on the ROM card, thus not having to load it into the RAM. And this was a very popular way to load BASIC back in the day because it saved a tremendous amount of space. So, and I'm going to show you inside the machine as well the different cards that are here. So right now I have it loaded, and there's a couple of cool features of cassette BASIC that I will show you as well. So the first thing about it, the first generation of BASIC, is that the first generation of BASIC, everything had to be capitalized. So in this version, as you type, you can use lowercase as well, which makes it just easier to deal with. So one of the things I'm going to do right now is I'm going to escape out from this, and I am going to go to my little handy Arduino program that I wrote, which I used in some of my other examples, and I am going to load tic-tac-toe, which is already preloaded on the Arduino, and basically all it's going to do for me is send it serially into the serial port that's on this machine. So I'm going to hit 1, and now it's starting to load the data to play tic-tac-toe. And you notice that this program has been written where the line numbers, in BASIC you have to have line numbers. Every line number is identical, or not identical, they're repeating each other, but there's no spacing between. So 24, then line number 25, then 26, then 27, then 28, then 29, etc., etc. And I'm going to show you two very, very powerful functions that were part of this release of BASIC, which made it very popular. So right now I'm loading it via a terminal. In one of our next videos, I'll be demonstrating a paper tape reader, because this program can be completely done on paper tape. And with paper tape, you'd be able to load any BASIC program you had with paper tape. When we demonstrate the Altair with extended BASIC, extended disk BASIC, that was when Altair and BASIC allowed for the 8-inch floppy disk drive. So at that point, you actually use basic commands within Microsoft BASIC to actually load programs or save programs on a floppy disk. This machine could handle loading into a cassette interface. I don't have a cassette interface hooked up to it, so I am simply working directly through the terminal. So I'm going to go back into terminal mode right now, and if I type list, it's going to show me the program that we just uploaded that is coming directly. And you can see some of the lights running here on the machine as it's actually showing us the program that was uploaded. So I'm going to run the program as is, just so that you can see it run. And this is a quick program of tic-tac-toe. And then I'm going to show you two really cool functions, and then we'll also do a examine next function. So I'm going to type run, and the program starts running, and basically it asks whether or not you want to go first. I'm going to let it go first. So it's now drawn itself right in the middle. So the board's laid out as 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to go position 9. And now we put an X there. So in order to block, I need to go to position 2. And it's going to want to put 1, 2, 3, 4, 5, 6. So let me block 6. Okay, it won. Because 6 was here. That was 7. Okay, so I'm not going to play again. The other nice thing is that now you have a control C, which allows you to break the code. So two things I want to show you. The first thing, there is a function in this version called tron, which basically does let you see where you are as you're executing the code. So when you saw me run it, you just saw the program run from the print statements. Now when I run it, it's actually showing me all of the line numbers to what it's executed at that particular time to help me better troubleshoot my program. So this is very useful when you're writing a piece of software because it's actually showing you where are you in the particular software. So once again, I didn't hit that, so let me hit 0. And now it's showing me exactly what the line numbers are that it's running. And I'm going to shut this off and then I'm going to show you one other really cool feature. So PROFF is shutting it off. So when I listed it, you notice that the line numbers were just right back to each other. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I purposely did that so I can demonstrate this next feature on the computer. Now let's say you wanted to add something between line number 75 and line number 76. Well, you can't. So you would have to renumber. And this is one of the biggest problems of writing software with line numbers, is that as the program keeps on growing and you make modifications or changes, you may need to renum. So this version of BASIC and all the basics forward had a feature called renum. So we're going to type renum, and then I'm going to do space and tell it by how do I want to renumber it by. And I'm going to say now increments by 10. So when I hit enter, it's going to run. It's done now. And when I type list again, you'll notice that everything now is by 10. So 10, 20, 30, 40, 50, 60, 70, and any place where there was a go subs or go tos, or any place where you called a line number, it matched those with whatever the new line number is. So now I have 10 spots in between each of the different codes that I can run. And I run this again, and you'll see this runs great, just like it did before. Exactly, identical. So the other cool thing I'm going to show you real quick is as a program runs, and I'm going to, let me break this, and let me write a simple little program right now, because it will make it easier when we do it. So I'm going to do a quick reset of the computer. I'm going to put back in my memory size. And I'm going to write a little program in 10, print, hello. I list that program, it prints hello. I'm going to type run, and it prints hello. So what I'm going to do now is when I go to run it, okay, I'm going to stop. I'm going to stop it. So as soon as I hit run, I'm going to hit the stop switch before it actually starts running. So hopefully I can do this quick enough. Nope, I wasn't able to do it quick. That's okay. So let me run it. I'm going to continue to run it. What I'm going to do is I'm going to stop it before I hit the end button. So now I've stopped the machine. So at this point, I am going to now go single step, instruction by instruction. So I'm going to code in the end. So I'm going to go one at a time. I'm going to hit the end, and you'll see on the screen, the end will show up in a second. And I'm going instruction by instruction by instruction by instruction right now. And the end just showed up. I'm going to hit return. And as we're executing now, instruction by instruction by instruction, eventually we're going to see the H show up to start spelling out hello. And I can either do single instructions, so we can go one by one, like this, and I'm executing each instruction one by one, or I'm going to go into slow, which is basically doing it instead of me clicking it one by one. And you're going to see on the display, an H will show up pretty soon. And it takes this many instructions to get to the point, because BASIC is a high-level language. And it has to get compiled down to machine code into the computer. And it's interpreting this, and then eventually it has to get down to ones and zeros for this computer to run it. And you're seeing it's processing these instructions just to print the word hello. And pretty soon we're going to see the H show up on the display. And that means we've gotten obviously to the first letter that it's running through. And it's running through all these instructions here to get to the point to interpret what does print hello mean at the level of getting into machine code. So pretty soon we should be seeing the H show up, and then I'll hit run to show it run for all the other instructions. But you can see how it's running through it, and it's giving us what is the address and what's in the data of the memory of this machine. And we're not using much memory to run a program that says hello, which is pretty small, but you can see how many instructions it has to run through to just start printing that first H. And that's really all I want to see, and then we'll hit the run button. It should be here any second at this point. We should be seeing that H show up in this instruction. What's nice about this is as you would be troubleshooting, either there's the H. So the H just showed up of our hello. The nice thing about being able to single step is you can do instruction by instruction on the machine and do this. This was the last model that shipped with this type of flipping switch interface. Machines further on came with a direct interface that you basically talk to the memory of other things directly through a command line interface. When we demonstrate some of the other machines that we have, you'll see that there will be bootloaders and other direct interface software that allows you to skip putting things in, which are switches, and talk to it directly. So what I'm going to do now is I'm going to hit the run button, and once I hit the run button again, you're going to see the HELLO come in right away. There we go. It's done. So imagine all those steps when I click just run, and there's the program right there. So I hope you enjoyed this brief overview of the Altair 8800B with the Microsoft cassette BASIC ROM card inside. These are great machines. This was the last of the series of the Altair 8800s. And I hope you enjoy this, and we look forward to producing some additional tapes in the future. Thank you.